Hello, my name is Ryan Cottage.
And my name is Andrew Vickery.
For our extra credit project, we chose to talk about sludge and the process it goes through from the wastewater treatment plant and its applicable uses after the fact. When wastewater is treated at a plant, the large objects and the solids are removed, and leaving the water with a large amount of suspended solids. These solids are removed by a series of two sedimentation basins. These basins allow the water to settle out. The solids are then collected at the bottom of the sedimentation basin and are known as sludge. The sludge is then disinfected and then dewatered. At this point, the sludge becomes biosolids, but these two terms are often used interchangeably. There are two classifications of biosolids, Class A and Class B. Class A biosolids is dried and pasteurized and can be applied for land use. Class B includes all biosolids not represented in Class A and is volatile. Class A is a higher quality and can be applied to use just outside of general landfill disposal and incineration. These Class A biosolids are further treated to help reduce odor and remove trace pathogens or heavy metals. 23% of all biosolids are made to meet Class A standards. The most common use for biosolids is in a land application as a fertilizer. This is a much better alternative than shipping the sludge off to a landfill or burning in an incinerator. In the past, ocean dumping of biosolids was allowed and a very common method for larger cities to get rid of the unwanted sludge. However, in 1988, the federal government banned ocean dumping of sewage sludge, causing some larger places like New York City to find new alternatives to get rid of the sludge. One more recent incident of New York trying to find new ways to get rid of its unwanted sludge was the infamous poop train that was in Parrish County, Alabama. A train full of sewage biosolids was sent from the city down to Parrish County to be disposed of in the nearby Big Sky landfill. Local residents of the area, however, were outraged by the terrible smell left lingering in the air from waste that wasn't even from their state. After the outrage, more truck drivers were brought in to help remove the sludge quicker and get the train out of the area. This helped to bring to light major issues of disposing of biosolids and how more sustainable solutions need to be found, such as biosolid land application.
Biosolids are most commonly used as fertilizers in agricultural farming, but can also be used in parks or for reclaiming mine sites. Approximately 7.1 million tons of dry biosolids are generated every year in the U.S. alone. Of those 7.1 million tons, 55% are land applied, with the rest being sent off to incinerators or landfills. Biosolids used for farms are better than traditional chemical manure-based fertilizers for many reasons. Compared to chemical fertilizers, which is often petroleum-based, is cheaper and has reduced effects on greenhouse gas emission. It is also a much safer alternative to manure fertilizer, since manure fertilizer is generally untreated, unlike biosolids, and has a greater risk of passing pathogens or other harmful materials onto the soil or humans. A 4-year-long test was performed by the United States Geological Survey on Denver on the land application sites where biosolids were being used as fertilizer, and tested the effects of the biosolids on groundwater, soil, and surface water, and found that there was no measurable effect on the concentration of undesirables in the surrounding area. Though the choice seems clear that all counties and municipalities should use their biosolids for land application, it is not clear-cut. The biosolids do have an odor, and according to the Center for Food Safety, there are claims that food produced on farms using sludge have been harmful to humans. Local governments will have to weigh these pros and cons as they make decisions.
King County in Washington has made leaps and bounds by developing a highly sophisticated way of putting sludge to land application. Some counties and cities in Alabama have been very accepting of the use of biosolids in their applications, while others have fought against it. The city of Dothan, Alabama produces 1,414 tons of biosolids in 2013, and 742 tons of that went directly to land application. Residents of Jackson County, however, fought back against the use of biosolids on local farms. Denali Water Solutions was giving out biosolids that met the required standards for land application for free to local farmers. but after an uproar about the smell, are having to look at possibly getting rid of the program altogether.
The city of Tuscaloosa chooses to burn its sludge that is gathered at the wastewater treatment plant, and the sludge from the drinking water treatment plant is sent to a landfill. The city has budgeted over $5 million for its wastewater treatment plant this year, and around $6 million on its 2 drinking water plants. Some of this cost could be offset by selling the sludge. The 1,118 acres of irrigated farmland in Tuscaloosa could also stand to benefit from the selling of sludge, for it is much cheaper than traditional fertilizer.
With the population constantly increasing, disposing of biosolids will continue to be a long-term issue and become more and more of a problem. We need to create a long-term viable solution other than burying a landfill or burning it in an incinerator. Using biosolids as a cheap, safe alternative for your regular chemical or manure fertilizer is the future and the way things are going to keep going, in my opinion. I would not be surprised at all to see in the near future close to 3/4 of all biosolids being used in some form of land application. While there are many drawbacks, mainly surrounding the smell, a cheaper product for something consistently used by farmers will be hard to pass up in the future. With prices constantly rising, any way to cut down on your margins will be a welcome change for farmers and others who will take the initiative to change to biosolids.
I hope to see the city of Tuscaloosa begin an initiative to sell its biosolids. This will show that the city prioritizes sustainability and is a forward-thinking city.
For our 3 questions, the first is, how much of biosolids produced are being applied for land use in the U.S.? A, 10%, B, 25%, C, 55%, D, 80%.
Tons of dry biosolids does the U.S. produce every year? A, 5.2 million, B, 7.1 million, C, 9.8 million, or D, 11.4 million?
And the final question is, what was this presentation about? A, biosolids, B, drinking water, C, recycling, or D, air pollution?